Theorem 4 is going to be used in example 6 here, where we're asked to work with some hyperbolic trig functions. These do show up occasionally. You will see them again. You will see them again in Calc 2, Calc 3. They do show up in various physical science courses. But I'm not going to lie, you won't be working with them a ton. So don't worry about memorizing all of these bottom four. Really, you just need to know these top two. And the reason why they're called hyperbolic sine and hyperbolic cosine is because they have some properties that are similar, but not necessarily identical to properties of regular sine and cosine. So in this case, like sine and cosine, the derivatives flip back and forth between the two of them, but unlike regular trig functions, the derivatives don't, for instance, the derivative of hyperbolic cosine is not negative hyperbolic sine. There's no sign change between these, which differs from the derivative of cosine. That, of course, we know is negative sine of x, so there's this sign change that happens when you go from cosine to sine, but not sine to cosine. So do not, although they are similar and they are named because of their similarities, they are not identical. So not every property you know to be true for sine and cosine is going to be true for sinh and cosh. But with that out of the way, let's go ahead and calculate this. This is not going to require any logarithmic differentiation. This is just where they show up in the book. So we're going to go ahead and take the derivative here. So y prime is going to be, well, we've got a chain rule here, because really cosh squared is no different than cosh of x times cosh of x. So this would be 2 times the cosh of x times the derivative of the inside. Well, what's the derivative of cosh? Sinh. Minus 2 times, leave the inside alone, multiply by the derivative of sinh. That's cosh. Well, they cancel, so we get that the derivative y prime is 0. What exactly does this mean? Well, there's a reason why I gave this example. One, it's to get practice using and working with sinh and cosh, but also this is a defining identity of hyperbolic trig functions. So this is a little aside here. We all know that sine squared x plus cosine squared x equals 1. We know that. But with hyperbolic sine and cosine, there is another identity, and that identity is cosh squared x minus sinh squared x. That's 1. So the difference in this case between cosine and cosh squared and sinh squared is 1. The reason for this is this identity comes from the fact that the unit circle has this format that's the equation of the unit circle. Well, there's another equation, x squared minus y squared equals 1. This is a hyperbola. Hence the name hyperbolic cosine and sine, because they come from this type of formula. So there's a little relationship there. They do show up from time to time.